Hi, so today we're going to be talking about the separation of a mixture lab that you'll be doing at home using your eScience kit for this lab. Now, this lab is very different from all the other labs you're doing. Number one, I did not provide you with a procedure. Big part of the day's lab is to practice critical thinking skills to come up with a procedure to solve a problem. Number two, rather than filling out a worksheet, you're going to be writing a full lab report on this, including your full written procedure that needs to be written in enough detail that somebody else can come along and follow and do exactly what you did. So let's first look at the things you may need to include to do this lab. So the first thing is in an envelope, it says types of matter. Now, of course, we're going to be using this to do a separation of a mixture lab, but inside of this envelope, you should have had filter paper and then a mystery sand and salt mixture, and it says must weigh amount because you're not going to be using all of it, and a scoop. So the idea is this mixture is made up of three components: sand, which we're often over sand, salt, by salt I mean sodium chloride, table salt, and then another type of salt, salt being a soluble ionic compound, ammonium chloride, NH4Cl. Now, ammonium chloride and table salt are both water soluble. So the high school version of this lab was just salt and sand, and it asked you to separate the mixture. So dissolve the salt in the water and filter out the sand, and you've separated the mixture. By adding a third component in, now you're going to have to do more critical thinking to figure out how am I going to separate it. The idea at the end of the lab, the main objective, is to determine what the percent composition is of these three components, to calculate it, if you will. So you don't need to actually, in the end, have three separate bowls with the three separate components in it. You just at least need to know what were their masses so that you can calculate the percent composition. You're going to do this for 2 trials, and then compare trial 1 to trial 2 to see if you get consistent results. And if not, be able to explain a possible reason why you didn't get consistent results. So your salt and sand mixture, you're going to weigh out approximately 2 grams. So your weigh boats that also came in your kit, weigh out approximately 2 grams of this, and then come up with a method of determining what percentage of this is sand, what percentage of it is salt, and what percentage of this is ammonium chloride. Now, ammonium chloride and salt are both water soluble, so water alone would not be able to separate them. But something that does separate them, ammonium chloride sublimates at high temperature. Sublimation is the phase change that goes directly from a solid to a gas at high temperatures. You have to heat it up, in other words. That isn't going to happen if it's dissolved in water. I'm saying solid to gas, so you have to be a dry solid in order for that to work. And it happens pretty rapidly. Our little sterno lighter that comes in the kit is going to be hot enough to make this happen. So you have to come up with your own method of which component you're going to remove first, and there's more than one ways of doing this. I do this exact same experiment here in lab with my seated class students, and they all come up with different methods for doing it. If you want to, before you do the experiment, send it to me in an email and ask for my feedback. I'd be happy to give you feedback on your procedure. Some safety notes, though. We'll be working with heating up glass. So on top of your sterno, we have a support, have glass beakers to heat them up. When the glass is hot, of course, use your tongs or your insulated glove to move the glassware. But make sure once the glass is hot, you don't let it come into contact with anything cold. That means if you heat it up for some reason and then later decide that you want to, add cold water, don't add cold water to the hot glass because it will cause it to shatter. Transfer your mixture to some other container, another beaker, and then add cold water to that. Also, these weigh boats are plastic, so if you touch something to them that is very hot, such as the side of a hot beaker, it will melt the weigh boats, so be careful of that. By the way, these weigh boats do have mass, so you do still have to tare your scale when you have the weigh boat on it before you add anything to it. Otherwise, it will look like there's no mass there. Be specific in your lab report of what each step entails. Never say something vague like, step 4, add water, because then the person who's trying to copy your results doesn't know how much water to add. So say, okay, step 4, add 50 milliliters of water. In your procedure, precede it by a materials list that includes all the materials that you used. And make sure that you label how many milliliter graduated cylinder. Make sure you say a glass beaker, what size beaker. We have a Erlenmeyer flask and a funnel. Filter paper might be useful. Now, to make filter paper fit into a funnel, the best way to do that is to fold it in half, then fold it in half again. So you have this little pizza slice. Now, if you look at it from the side here, and you can pop open part of it, now you've got something that looks like an ice cream cone, and that will fit down in there. If it pops up, try adding a little bit of water, that'll wet it down. Now remember, we only want to know the mass of the individual components. So if you've got sand here, and say it was filtered out of water, that means that sand is now wet. Don't just go ahead and weigh the mass of the sand, because that sand is wet, it's got water in it. You'll get the mass of the water too. So make sure whenever you're recording a mass of a component, you make sure that component is dry before you record its mass. Also, make sure that at the end of the day, you've got all these components, you've determined all of their masses, you explain directly from your procedure to your results where each number came from. Don't just say, step 7, record the mass. Well, record it as what? Record it as the mass of salt, sand, salt and sand, salt, sand, and ammonium chloride. Tell them what they're recording so that they know where does that go into the procedure, into the results section. Your lab report results section will have 2 different parts. It will have the quantitative data, that's your tables that need to be labeled with units that say, okay, this is how many grams we started with of the mixtures, how many grams was ammonium chloride, etc. And it also needs to have a qualitative section. That means you made observations. We observed this during the step 2. We observed, that kind of thing. Make sure you make observations there. Now, the lab report format is on Blackboard, the lab report format and the rubric that I use to grade these lab reports. Pay close attention to the format because you can lose points if you do not follow the format. The first part of the lab report is the title page, and it tells you what all needs to be on the title page. The second part is going to be the objective statement. The objective statement, this is not an introductory paragraph, this is a statement. So 1 sentence. That being said, it's probably going to be more than 5-word sentence. But make it include the primary objective, but you don't have to go into deep detail, but the primary objective of this experiment. What were you trying to do with this experiment? Then, after the objective statement, you'll have your materials list and your procedures. I prefer procedures to be numbered, step 1, step 2, step 3, but a good paragraph style procedure, if it's done very well, can also work. After the procedure will be your results section. After the results section, you'll have your conclusions. The conclusions draw a direct relationship between your results that include all of your calculations, and of course show work for calculations so you won't get credit. Direct relationship between the results and your objective statement. So show in the conclusions that how exactly, in detail, you met your objectives. Your results go back to the objectives. And also discuss the results as far as other observations. What can you determine? Did you spill something at some point? Make sure you record that because that's going to cause your numbers to be different. Anything that happens, even if it is a mistake, you need to record that in your results section. That way, if your result numbers don't seem to make sense, in your conclusions, you can state that. The numbers were lower than normal because there was some sand we couldn't get out of the bottom of the beaker. Put that in your conclusions, but make sure it's referencing something that was mentioned in your results. Otherwise, it's just sitting alone there with nothing to back it up. So you need to document everything. And then after the conclusions, there are 2 post-lab questions that you'll get from the handout that need to be answered. Make sure that those calculations for percent composition are showing all of your work for them, for trial 1 and trial 2. So you're going to do this twice. So make sure, again, you wear safety glasses, safety gloves, safety first. If you end up using this, stirring rod, all that kind of stuff now, ammonium chloride, I did say it sublimates. That means it goes directly into gas phase. So that vapor, it's not very harmful, but it's not the kind of thing I would breathe deeply in. So make sure when you're doing this lab, You do this in a well-ventilated area. Do it somewhere that either has an exhaust fan that hooks outside, or by an open window or an open screen door or something, or even outside on a patio. That way you're not breathing in the fumes. They're not really dangerous, but they could be a mild respiratory irritant. And certainly don't do this right underneath the smoke detector, because it's not smoke, it's vapor, but it can still mess with smoke detectors. So I recommend doing this. Make sure you're well ventilated area before you do it. If you have any other questions, please don't hesitate to send me an email. I'll be checking my email all week. Have fun.